So this one is assignment related to standing waves. In the last session, we discussed first 7 questions, and today we'll discuss from question 8 onward. So in this question 8, in a piano, a note is produced by striking the stretched wire with a hammer. So which of the following describes the wave produced on the wire? So how we can identify the wave produced? Because if it is a string, and when the hammer strikes this string, so string will vibrate to and fro, and it will produce waves which will travel in opposite direction, give rise to a standing wave. So initially transverse waves are there, and these transverse wave will interfere because they're traveling in opposite direction, which result in a formation of a standing wave or a stationary wave. Why it is transverse? Because the vibration of the particle is perpendicular to the direction of the wave. And why it is a stationary? Because two traveling waves combine together, moving in opposite direction, give rise to a stationary or a standing wave. The next question: the wavelength of a progressive wave is defined as the distance between adjacent points on the wave. Which, so how we explain the concept of the wavelength? So, example, if we have a progressive wave, it can be longitudinal or it can be transverse. Like example, if this was a transverse progressive wave, so distance between the two successive crests is known as the wavelength, or distance between the two successive troughs is also known as wavelength. So if this is a crest, the other point is also a crest, so the point, they are in phase. So distance, the wavelength of a progressive wave is defined as the distance between the adjacent point on the wave which are in phase or vibrating in the same manner. So C will be the right answer for this. Next, question 10. Which of the following expression gives a phase difference in radian between 2 points of wave which are 1 meter apart? The frequency is given and the speed is also given. So, as we know, the relation between the phase difference and the wavelength, the wavelength and the phase difference, that if the part difference in terms of wavelength is lambda, then the phase difference will be equal to 2 pi. And in this question, what we want, which of the following expression gives a phase difference? So we need a phase difference in radian between 2 points on the wave which are 1 meter apart. And what is the wavelength here? So when you work out the wavelength, lambda is equals to, because v is equals to f lambda, so lambda is equals to v divided by f. So v is equals to 340, and the frequency of the wave, that is given 160. So when we work out, when the wavelength, because when one wavelength is there, that is having a phase difference of 2 pi. And here, what is one wavelength? One wavelength is equals to 340 divided by, so instead of writing lambda, we can write 340 divided by 160. So if the lambda is 340 divided by 160, the phase difference will be 2 pi. But if the wavelength or the distance is 1, then this will be x. When we cross multiply, so x is equals to 2 pi, and this divided by 340 over 160, so it will come out as 160 divided by 340. So it matches with option C. Is it clear? Yeah, it's the same idea. Like, because in terms of length, because what we did, we get a relation between the length and the angle. That we know the relation between when one wavelength is there, that the phase difference is 2 pi radian, and here one wavelength is actually 340 divided by 160 is equals to 2 pi radian. So if they are 1 meter apart in terms of wavelength, if they are 1 meter, then this will be x. So when you cross multiply, it will come out as 2 pi multiplied by 160 divided by 340. Is it clear? This question? Question 10. Moving on to the next question, question 11. Two coherent sources emit the wave, and the wavelength lambda is in phase at a point where two waves meet. They have a phase difference of 90 degree or pi by 2 radian. Which of the following could be a part difference? So how we can work out the part difference? As we know that the relation between the phase difference and the part difference, so when we relate the phase difference with the part difference, so when the phase difference is equals to 2 pi, so when the part difference is lambda, the phase difference will be equal to 2 pi radian. Now, if the part difference is pi by 2 radian, if the phase difference is pi by 2 radian, then the part difference will be x. So when you cross multiply, this will be lambda multiplied by pi by 2 and divided by 2 pi. So pi will cancel with pi, and this 2 is divided, so it will come out as lambda by 4, or quarter of the wavelength. So D will be the right answer for this. Is it clear? Question 11. Another question, as this topic is related to standing wave, so you will find the similar questions. Repetition is also there. In question 12, two loudspeakers produce identical sound of frequency 440 Hz, which superimpose to produce a standing wave. The adjacent nodes are formed, which are 0.75 meter apart. Select a correct statement about the wave. So the adjacent nodes, the distance, because when it is forming a standing wave, so this is node, node, and node. So distance between the adjacent nodes is known as a lambda by 2. So they mention here that distance is 0.75 meter. So if the distance between the adjacent nodes is 0.75, what will be the wavelength? Because the distance between adjacent node is half of the wavelength, so full will be twice of this, so it will be 1.5 meters. So actually the wavelength of this standing wave is equals to 1.5 meter. So when we check the option, the frequency heard is 880. That's not the right answer because it is 440 and it is not a Doppler shift, so it does not change the frequency. The speed of the wave is 165 meter per second. How we can work out the speed of the wave? We know v is equals to f lambda. So 440 multiplied by 1.5, because we know the wavelength is equals to 1.5. So 440 times 1.5, that's equal to 660. So 660 meter per second, so it cannot be B. The wavelength is 1.5, so it will be C is the right option. What about D? The wave are traveling in the same direction. It cannot be, because the wave should travel in opposite direction to give rise to a standing wave. That's why C is the right statement for this question. In question 13, the diagram shows an experiment set up to demonstrate two source interference using a microwave. So microwaves are produced and the two waves interfere at point P. The detector is moved from O upward. The arrow is shown. The first position where the signal is minimum is P. So signal is minimum, it means it's a destructive interference. So here we got maxima, constructive interference, then this is the first minima where destructive interference take place. So when destructive interference is there, the path difference should be lambda by 2, because the condition for destructive interference, the path difference should be lambda by 2, 3 lambda by 2, 5 lambda by 2, and so on. So the path difference here, because of minima, so it should be lambda by 2. But how to calculate the path difference? Like distance moved by from S1 to P, so that is the distance moved by from first source, and distance moved from S2 to P. So when we take a difference S1P minus S2P, that will give us lambda by 2, as there is a destructive interference, so D will be the right answer for this. Yeah, S1P is longer compared to S2P. So that's why when we take a difference, so S1P from S1 to P, that is the distance traveled by the first wave, and from S2 to P, that is the distance traveled by the second wave. So when we take a difference to get the path difference, so distance from S1 to P minus distance from S2 to P, you will get the path difference. And because it's a destructive interference, so the path difference should be equal to half of the wavelength. Standing wave produced by interference. Two coherent sources emit a wavelength which are in phase. Two waves meet at a point and they have traveled slightly different distances. The wave now have a phase difference of 180 or pi radian. Which of the following could be a path difference? So we know the relation between the path difference and phase difference. That if the path difference is lambda, then the phase difference will be 2 pi radian. And if the phase difference is pi, then the path difference will be x, then cross multiply. So x will be equal to pi lambda divided by 2 pi. So this will cancel with this, so it will be lambda by 2. So value of x is lambda by 2, so B will be the right answer for this question. In question 15, standing wave produced by interference, the wave of wavelength lambda from a source divide along two paths and recombine to travel different distances. At which point at the point where they combine, which line of a table would show the corresponding phase difference, part difference and phase difference of the two waves? So which line is corresponding the part difference and phase difference? If part difference is lambda, then the phase difference will be 2 pi radians, so it cannot be A. If part difference is lambda by 2, then the phase difference should be pi only. If the part difference is lambda by if the part difference is lambda by 2, then the phase difference should be pi, so C is the right answer. Is it clear? Question 15. So we simply have to use the concept, a simple ratio between the phase difference and the part difference. A beam of light travel a distance x to arrive at point. A second beam of light of same frequency, initially in phase with the first beam, travel a distance y to arrive at same point. For a destructive interference to occur between the two beams, the path difference x minus y must equal to, so the path difference, because we want a destructive interference. So as we need a destructive interference between x and y, so path difference should be lambda by 2, or we can say 1 lambda by 2, or 3 lambda by 2, 5 lambda by 2, 7 lambda by 2. So this is the odd number, 1, 3, 5, 7. So it should be odd number of half wavelength. So C will be the right answer for question 16. Is it clear? In question 17, a longitudinal wave is moving along a spring and 2 points on the spring are separated by half wavelength. The displacement of these 2 points are always, so when they're, because a longitudinal wave is there which is moving and 2 points of a spring are separated by half wavelength. So like if you have say compression where the particles are closer, then you have rarefaction, and then you have compression. So this total distance between the two successive compressions, that will be equal to lambda. But distance between compression and rarefaction, that will be half wavelength, not the full, like from centers. So this will be lambda by 2. So particles in compression and particle in rarefaction, they will move in opposite direction. That is why C will be the right answer. Is it clear? Because they simply ask about longitudinal wave, they did not ask about the standing wave. Because for standing wave, if the same question was there related to standing wave, then when two particles are lambda by 2 apart, then they will be in phase. Because like this is node, then this will also be a node, and the particles, they will be in phase, like they will have the same pattern of vibration. But in the question, they did not ask about a standing wave, they simply ask about a longitudinal wave. So one longitudinal wave is there and the particles are wavelength, half of the wavelength apart, so they will move in opposite direction. In question 18, which of the following is standing wave? Light emitted as a line spectrum, so that is progressive wave, but it should, because in a standing wave it should two waves to travel in opposite direction to give rise to standing wave. So it cannot be a ripple of water when you from a stone thrown into a pond, same thing, it will produce progressive wave. Sound from an opera singer in a theater, that is not producing a standing wave, but when a vibration of a violin string, because what happened when we pluck the string, so it produces two waves which travel in opposite direction and give rise to the standing wave. So D is the right answer for question 18. In question 19, the diagram shows the displacement time graph for two oscillation x and y. Which of the following statement correctly describe the phase relation between them? So when we work out the phase relation, so x already completed, because when we work out the phase relation, both waves should start from same point. So like as you can see, for a y the wave started and x already it started, and how much it already completed? It complete the phase of 90-degree, because when you work out the phase for the wave, so this is 0, 90, quarter of a 90, half 180, then 270, and the last one is 360. So how much we have to produce x, or x has already completed, so x has already completed 90 degrees or pi by 2 radian. That is already completed by x. So it means x is ahead. So x is pi by 2 radians ahead of y. Is it clear? Because x already completed that part and x we are taking from this point. But y vibrations just started. So it means x is already completed quarter of the wave or pi by 2 radian compared to that of y. So it means x is ahead of y. And it's a displacement time. Question 20, the diagram below shows a standing wave on a string. So this is a standing wave on a string. You have point x. What point x is representing? Point x is representing nodes. And point y is representing antinode. So phase difference between the progressive wave at x, because node is formed by a destructive interference. So if the destructive interference, what should be the phase difference? Phase difference should be pi radian or 180 degrees. And antinode, it is formed by constructive interference, so phase difference should be 2 pi or 360 degrees for constructive interference. That's why B is the right answer for question 20. Is it clear, this question? Because we need a phase difference between the two progressive waves which result in a formation of this standing wave. Question 21, the diagram represents standing wave. Which diagram correctly shows the position of nodes or antinodes? So when we work out the position for nodes and antinodes, this is wrong position, this is right, antinode is wrong, this is right, right, right. So C is the right answer, because antinode is a maximum displacement, not the minimum displacement. So that's why C is the right answer for question 21. Question 22, the diagram represents standing wave. The length of a string is 4 meter. State the wavelength. So what will be the wavelength? As we know, this is 4 meter. We have node, node and node. So distance between two successive nodes for a standing wave, that is lambda by 2. And distance between three successive nodes, that is equals to lambda. So here actually lambda is equals to 4 meters. So C will be the right answer. Question 23. Two speakers S1 and S2 are placed 11 meter apart. So they are 11 meter apart and connected to a signal generator which produce a wavelength of 2 meter. The sound waves emitted from S1 and S2 are in phase. Point X is 5 meter from S1 and 6 meter from S2. So how many wavelengths are there? Because one wavelength is equals to 2 meter. So it will be 2.5 wavelengths and this will be 3 wavelengths. And the part difference between them, 3 wavelength minus 2.5 wavelength, that is equals to 0.5 wavelength, or we can say half wavelength. And whenever the part difference is half wavelength, which is we'll have a destructive interference. So the phase difference should be pi radian. So question 23. So when we compare these two waves, as the part difference is lambda by 2, phase difference is pi radian, so this will result in a destructive interference. So when it results in a destructive interference, at this point they cancel out the effect of each other, or the particles will be anti-phase at point X. This cannot be ahead. Why we cannot compare this? Because the waves are ahead or lagging when they're traveling in the same direction. But in this example, two waves are traveling in opposite directions, so we cannot say or compare which one is ahead or which one is lagging behind. So we can compare whether they're in phase or anti-phase or constructive or destructive interference only. That's why C is the right answer for this. Question 24. Standing wave are created in a pipe of length L. The pipe closed at one end and there is antinode at the open end and node at the, what is the length of a corresponding lowest? So it's a closed pipe, the pipe which is closed from one end. So it form antinode at open end and node at the closed end. And we know the distance between node and antinode, that is equals to lambda by 4. So length of this pipe is equals to quarter of the wavelength. So we can say lambda by 4 is equals to L, or lambda or wavelength is equals to 4 times L. So D will be the right answer for question 24. Because the distance between node and antinode is quarter of wavelength. Distance between two successive nodes or two successive antinodes, half of the wavelength. And distance between three successive nodes or three successive antinodes is equals to full wavelength of a standing wave. Question 25. So a source of a sound move at a constant speed toward a stationary observer. This is related to a Doppler effect, that relative change in frequency due to motion of source or observer. So when a source of a sound move towards the stationary observer, so what we observe, the frequency will increase and the wavelength will decrease. The frequency observed will be higher because the wavefronts are compressed or the wavelength is shorter. So B is the right answer. Question 26. Two waves, each with a wavelength of 2 centimeter, leaves a single source in phase and combine at point A. So the wavelength is 2 centimeter. So we can say lambda is equals to 2 centimeter. Now what is the distance travel? This is the source, so 2.5 plus 2.5, so that's equal to 5. So this path is 5 centimeter, and this part 4 plus 4, 8 centimeter. So 8 minus 5, that is equals to 3 centimeter. So 3 centimeter is a part difference in terms of wavelength, because one wavelength is 2 centimeters, so 3 centimeter will be equal to 1.5 wavelengths. And if it is 1.5 wavelength, 2.5, 3.5, it will be a destructive interference. And when there is a destructive interference, the phase difference should be pi radian. So C is the right answer. Is it clear? Question 26. In question 27, the student draws the pattern formed by a standing wave in a string. Determine the wavelength. So how we can determine the wavelength? This one is node, 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 and node. So there are 4 nodes. We know 3 successive node, that is lambda, and 2 successive node is lambda by 2. So actually it is equals to lambda plus lambda by 2, or we can say 1.5 lambda. So we can say 1.5 lambda is equals to 96 centimeter. So lambda is equals to 96 divided by 1.5, that's equal to 64 centimeter. Is it clear? W and X are the point on the string, as you can see. State the phase difference between W and X. So what is the phase difference between the point W and point X? Because yeah, the phase difference between them, as they're traveling in opposite direction, the point W, the particle tend to move towards the mean position, X also tend to move towards the mean position. That is why these 2 points are anti-phase, or phase difference will be pi radian. Describe how standing wave is formed. So this, you will find this question repeat many times, that the formation of the standing wave. So basic idea is that two progressive waves traveling in opposite direction, that give rise to a standing wave. The two progressive waves which are traveling in opposite direction interfere, give rise to of nodes and antinodes due to constructive and destructive interference. Yeah, that's right, Christopher. That meet form nodes and antinodes. Nodes are minimum amplitude destructive interference, whereas antinodes are for constructive interference. Question 29, state the principle of superposition. So the superposition principle state that when two waves will meet, the displacement is equal to sum of individual displacement. So when two or more waves meet, the resultant displacement is sum of individual displacements. Interference give rise to you whenever the two waves combining, you should always use the term interference. But this is called a principle of superposition. Principle of superposition state about the idea of the amplitude that when two waves combine, then the resultant amplitude is equals to sum of individual. Like example, say this is one wave and this is a second wave. So when they combine at certain point, say this was 2 centimeter and the other is say 5 centimeter. So the resultant wave, like this is 2 and this one is 5. So the result of these two, 2 plus 5, that will be 7. So resultant will be 7, the amplitude. That is principle of superposition. Is it clear? So whenever there is a principle of superposition, you will always use the term amplitude. So this was assignment related to standing waves. In the next session, we'll discuss another assignment. Any question related to the class today? So I'll end the session and share this with you.